Hello, Math AH. We are going to be doing lesson 4.3e, so get that one out. Again, this is a video, so if I'm going fast, you can always pause, go back, rewind, fast forward. You have control of the buttons, so do what you need to do. So we are going to do percents with models. That's what we did back in Module 1, and now we're going to put it into equations. So we're bridging Module 1 to Module 4. So yes, you do have to remember Module 1. To pass a test, you need 70% correct. There are 50 questions on the test. How many do you need to answer correctly in order to pass? So when we set this up back in Module 1, I used to talk about how we had to do our part over our whole equals our percent over 100. So we thought about this problem. We said, okay, we have 70%, so I know it's 70 over 100. And 50. There are 50 questions on the test. That's the whole test. So that's the whole. And we were looking for a part. So X is my part that I got correct. Okay. So back in the day, we took this and we simplified it. We went, okay, 70 over 100 is 7 over 10. So when we modeled it, we drew 10 cuts. 1, 2, 3, 4, 5, 6, 7. And we shaded 7 of them. Okay. My whole thing was 100%. And the part that was yellow, that was 70%. We know that my whole test is 50 questions. And we want to figure out what the yellow part was. So we went, all right, 50 divided by 10 is 5. So we know in each little chunk there is 5, 5, 5, 5. So we know if we have 7 5s, that this is 35. So then we figured out, hey, you have to answer 35 questions to pass. So we wrote it as a sentence. In order to pass, you must answer 35 questions correctly. Now, modeling is fine, but our numbers don't always work so nice to model. So we want to learn how to do it with the equations too. Now, we already learned this part, so we already kind of set this up. Now we just have to see, what is this equal to? So I think a little bit. I had my X over 50. Oops. Let's make it black. There we go. X over 50 equals 7 out of 10. Well, and they're using C. Okay, did it tell me how to use C before? No problem. I can make this a C because I wanted to put a C, so we can make that a C. Okay, I have to think which one's the same. Well, I know that 7 over 10, that's 0.7. So this is the same as 0.7. So 0.7 would be C over 50. That would be good. I know that if I was to solve this, I'd have to multiply both sides by 50, and that would simplify over to here. Okay, so this one, the C and the 50 are backwards. That doesn't work. This one, they made the 50 the part and the correct the whole, so they had their fraction upside down. So we know that the first and third one would match our setup. All right, let's do another one with modeling. Last week, Dirk jumped Y inches in the long jump. This week, he increased his length of his long jump by 10%. Draw a model to represent the situation. So we know our percent increase is 10%. Percent increase is 10%. And we know that 10% is 10 out of 100 or 1 out of 10. So I take my original model, break it up into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to increase it by a tenth. So I am adding an additional 10%. Okay, so the black right here is my original, and this 10% is my increase. Okay, so there's my model. I don't know what's going on. It said my original one was y, and my increase, well, I know it's 10% of y, so it's 0.10y. Okay, and I know that I'd have to get the whole thing, I would have to add them together. So which equation works? Well, here, my whole thing plus 10% of my whole thing. If I combine like terms, if I remember that this is a 1y plus 0.10y, and I combine like terms, I get 110% of y. Here, this is just the increase. Here, they actually decreased it. Okay, so we have to explain our answers. The first choice is just the increase. The second choice is a decrease of 10%, is the original minus 10%. The last two are great because they have the original plus 10%. Okay, move that up so the camera's not in the way. All right. So we're kind of trying to grow from the model. That's what we're comfortable with for Module 1. We're trying to build that into an equation, and eventually we're going to let go of the model, but not yet. Draw a model. So first I'm going to draw a model. I'm going back to what I knew in Module 1. Okay, then I'm going to define the variable and write an algebraic equation. So define the variable, 3, write an algebraic equation. Okay, and then we're going to solve it. And we are going to answer in a complete sentence. It's asking us to do 5 things. Sometimes when you're taking a test, you might want to number your directions so you actually do everything in the directions. Okay, so we first will draw. 30% of my books are science fiction. If I have 60 science fiction books, how many books do I have altogether? So I always think of my fraction, my part over my whole equals my percent over 100. That's my setup. 30%. So I have 30 over 100. If I have 60 science fiction books, well, 30% of my books are science fiction. So the science fiction is a part of the whole. So here, the 60 has to go on top. How many books do I have altogether? We're looking for the whole. Okay. So here, if I was to go back mod 1 and draw this, I have 60 over a whole equals 30 out of 100. That's 3 out of 10. So I make 10 sections, shade 3. Shade 3. Okay. I know that my whole thing is 100%. This yellow part is my 30%, which are science fiction books. I know that 60 is in this part. Oops, 100%. 60 is in that part, so each part has 20. So if I put 20 into 10 things, I'd have that there are 200 total books. Okay, so that's what we did in Module 1. Now we want to grow that over to equations. So I still started out the same way. I still start out with my 60 over W equals 3 over 10. Okay? So I can think that is the same as 60 over W equals 0.3. If I want to get W up top, I'm going to multiply W by both sides. I get 60 is equal to 0.3 W. I need to find my variable. W is all my books. Let W equal all the books. Okay, now there's so many ways you can write in equations. This is part of it. 30% of all my books are the 60 science fiction books. Okay, now I have to solve it with the equation. Easy enough to do. To solve this, this was my equation that I like. So is the top, but this is the nice one. I would have to divide both sides by 0.3. Okay, I know that 0.3, 60 divided by 0.3, that's the same thing as 600 divided by 3. Well, I know that that's 200. So 200 equals W. I've got the same answer. I did it with a model. I did it with an equation. They agree. Your method should not change your answer. So now I need to answer in a complete sentence. The question was, how many books do I have altogether? You have 200 total books. Okay, number 4, we're letting go of the model. Now, if you like the model, you can still model. That's fine. But you also have to do the equation. So make yourself bridge the equation. To find a variable for the unknown. Got it. Write an algebraic equation to solve each percent problem. State your answer in a complete sentence. Okay, I got 52 out of 60 questions right on the last history test. What percent correct did I get? So I'm still starting the same way. My part over my whole equals my percent over 100. So I got 52 out of 60 questions right. Well, 52 is the part, and 60 is the whole. And I'm looking for my percent. So that is my equation. It's not lovely yet, but that's my equation. I can write it different ways. I have to define my variable. Let x equal percent correct. I'm going to clean up my equation in my calculator. I am going to go 52 divided by 60. 52 divided by 60. I don't get a nice number. I get 0.86 repeating. I don't want to cut off the repeating because then I may be cutting off questions. Is equal to x over 100. I want to get the x below alone, so I'm going to multiply by 100. When I multiply by 100, I don't take away the repeating part. It's still there. I'm moving the decimal 2 spots over. I get 86.6 repeating equals x. So I got 86.6 repeating percent on my test, or I got an 86.2% on my test. I have to answer in a sentence. What percent did I get on? I get you earned an 86 2/3. You can write a repeating decimal fraction, whatever, percent on your test. It is a B, buddy. All right. Number 4, the fuel economy of a new sedan is advertised at 24% increase over the old model. If the new model gets 31 miles per gallon, what is the fuel economy of the old model? Okay, so I have to think about my startup here. I have to do my original plus the percent of my original is equal to my new. That's my basic startup. So I am looking for the old model. I'm looking for the original. So I'm going to say let x equal original model. or old model, whatever you like. Okay, I know that I have a 24% increase. So I have the original, which is x, plus 24% of, so 0.24, can't write percents on my equations, I gotta change it to decimal form, of x equals my new one, which is 31. Okay, then I need to combine like terms. So 1.24x equals 31. So some of you might come in over here with the start or the original. Some of you might jump right to here. Great. Either way is fine. Then I'm going to divide both sides by 1.24 using my calculator. If you don't have a calculator, you can do a tab on your computer or your phone. I get x is equal to 25. Okay, that's supposed to be the original. The original increased by 24%. The original is supposed to get you 31. Okay, so now I have to answer in a sentence. The original fuel economy was 25 miles per gallon. And now the new car can go longer because it can go 31 miles per gallon. Okay, again, you can pause, rewind, stop, start, however you need to go through it. Okay, last year the population of Minitown grew from 1,250 to 1,300. If the population of the town grows by the same percent this year, what will the new population be? All right, I've got some stuff to organize. You're not graded on your organization, but sometimes it helps. So I've got last year, this year, and then I've got next year. So here we go. I'm going to organize myself. Last, this, next, they talked about the population. Last year, the population of Minitown grew from 1,250 people to 1,300. If the population grows by the same percent this year, what will the new population be? So here, there's some kind of percent increase. I have to figure out what that is. And then I have to use it again to get to the next. Okay, so percent increase. I have to think about that. How? What is that? So when we get a percent increase, remember that we have the original, the start, plus a percent of the start is equal to our new. Okay, so my start was 1,250. And there's some percent, I don't know what it is, in decimal form. So x times 1,250 gets me to my new, which is 1,300. So my x here is what my percent in decimal form. Percent, let x equal percent increase in decimal form. Percent increase in decimal form. Okay, I can solve that. So when I solve that, the increase, it increased by 50 people. So I have to figure out what percent of 1,250, and I don't like writing my coefficient after my variable, 1,250 is equal to 50. So then I need to divide both sides. When I divide, the zeros cancel out. 5 going into 125. We get x is equal to 0.04. So it was a 4% increase. And now I'm going to do that, but I'm not doing it. I'm not increasing it by 50 people. It was a 50 people, but now I'm going to increase this by the same percentage. So it's not 50 people, it's a little bit more. So now I go again. I'm taking my new start, 1,300. I'm increasing that by 4% of 1,300 to get my next. Now this is really 1.04 times 1,300. If I want to go a little quicker on my calculator. So when I do that, 1.04 times 1,300, I get that there is going to be 1,352 people in my next population. Again, it doesn't increase by the same number of people, it increases by the same percent. Since you're going off a higher number, that 50 now jumped to 52 people. Okay, so here, 1,352. Answer in a complete sentence. The new population will be 1,352 people. Okay, you can always pause, try the next one, and then see if you did it right. That's a good way to learn too. Here we go. The contributions of the annual school fundraising campaign were 10% greater in 2004 than they were in 2003. In 2003, the contributions were 15% greater than they were in 2002. If the contributions for 2004 totaled $8,855, what was the total in 2002? All right, that's a lot of stuff. I'm going to organize. I see 2002, 2003, 2004. So I'm going to go ahead and organize. Again, you don't get graded on your organization, but it is helpful. 2002, 2003, 2004. We have campaign contributions, so you can get your person up to make the policies that you want. I reread contributions to the annual school fundraising campaign. Oh, this is just to get fundraising. Okay. To get the things in the school that you want. Were 10% greater in 2004 than they were in 2003. Okay, so here we had an increase of 10%. In 2003, the contributions were 15% greater than they were in 2002. Okay, so from here to here, we had an increase of 15%. Okay. If the total contributions totaled 8,000 of 2004 totaled 8,850. Okay. 8,855. What was the contributions in 2002? Okay. Now, what you can't do is go, oh, I'm just going to subtract 25% because it was an increase of 15%, an increase of 10%, so I can subtract 25%. No, because you increased off of a smaller number and then a smaller number. So you can't take, if you take a percent of a bigger number, you're not going to have the same numbers that went up or down. So here I am going to go think backwards. I'm starting here at X. So my start plus 15% of my original 0.15 of X is equal to 2003. Number for 2003. Okay, I know that here my X is my start. So then I'm going to be taking this and simplifying it. So X plus 1.5X, that's 1.15X, is equal to my number for 2003. So right here, what I figured out, that this is 1 0.15x. Now I have to take that and increase it 10%. So our start now is 1.15x. And I'm increasing that by 10%. So I'm multiplying 10% of 1.15x to get to my number for 2004. Well, I can clean that all up. So here, this is 1.15x plus, when I multiply something by 10%, I'm moving the decimal over, 0.115x. I'm going to combine like terms. I get 1.265x is equal to my number for 2004. So I know that has to equal 8,850. So finally I can get to my real equation. Okay, so 1.265x is equal to 8,855. I'm going to solve that. I'm going to divide by 1.265. So 8,855 divided by 1.265 is equal to 7,000. So I know that in 2002, they contributed $7,000. In 2002, $7,000 were contributed. Okay, that one was confusing. I have to go back and hear it again, then go back and hear it again. Sometimes it takes 2 or 3 times to soak it in. Okay, number 8. Jill bought a bracelet that cost $5 before tax. Sale tax came out to be 24 cents. What is the sales tax rate? Okay, so I'm looking for the tax rate. So I'm going to let X be my tax rate. Let X equal tax rate. Okay, so when you buy something, you need to pay the government some stuff. So we know that we have our price, the price that we see on our sales, like the price you see on the price tag, the price, plus the tax is equal to the final price, which it pay at the register. Okay, Jill bought a bracelet that cost $5 before tax, and she looked at the bracelet, the price tag said $5. But there's tax. Tax is a percent of the $5. Okay, and that's where we got to the final price. Now we know that just this part, just the tax, this part right here, came out to 24 cents. So 5x is equal to 24 cents. So to figure out the tax rate, I'm going to divide both sides by 5. $0.24 divided by 5. They are not in California because they are paying only a 4.8% tax, and ours is like 8.25. Okay, so we write it into a percent. So the tax rate was 4.8%. Kylie is training for a marathon. Her training regimen is to run 12 miles on Monday, increase that by 25% on Wednesday, And then on Saturday, increase Wednesdays by 25%. How far will she run on Saturday? Again, maybe you want to organize. That might be good. So we got Monday, Wednesday, and then we have Saturday. And we're running some miles. Okay, Kylie's training for a marathon. Her training regimen is to run 12 miles on Monday. Got it. Increase that by 25%. 25% increase. And then increase that by 25%. Okay, how far will she run on Saturday? So here our thing is going to be equal to x. So let x equal miles on Saturday. Okay, we first have to take 12 and increase it by 25%. We can write that in two different ways. We can write that as 12 plus 0.25 of 12. Or we can write that as 1.25 times 12 because you're really running 112%. And then we have to increase that again. So here, I am taking my 12 that I increased by 25%. So I multiply by 1.25. And then I'm going to take that and I'm going to increase that by 125%. And that's where I'm going to get how far you have to run on Saturday. So throw it in your calculator. Well, we know that 25% of 12 is 3. So first we're going to go 12 plus 3 is 15. And then we're going to go 25% of that. And we get down to 18.75. So on Saturday, she will be running 18.75 miles. All right, number 10. Each month, Papa Surf receives a 5% commission. Remember, commission is a percent you make on sales. So someone might say, for every $100 you sell of my stuff, you don't get the $100, you make 10% commission. So you will make $10 for every $100 you sell for me. Okay? Papa Smurf makes a 5% commission on all his sales of Smurfberry juice and a 6% commission on all his sales for Smurfberry pies. One month, Papa Smurf sold $7,900 worth of Smurfberry juice and made a total of $650 in commission. How much were his sales of Smurfberry pies that month? All right, that's a lot of stuff. So I have to think, what is Papa selling? Papa is selling some fancy juice and some fancy pies. All right. So we've got juice going on and we've got pies going on. Juice and pies. There is his sales. And then his commission is a percent of the sales. Commission. I'm just going to abbreviate it. Commission. Okay. So each month, Papa Surf receives 5% commission on all his sales of juice. So whatever his juice was, we're going to multiply that by 0.05 times whatever his sales were. Okay. And a 6% commission of all his pies. 0.06 of whatever this pie stuff is. One month, Papa Smurf sold $7,900 worth of juice. and made a total of $650 in commission. His total commission, $650. How much were his sales of pies that month? Okay, so that's what I'm missing. I'm missing my pies. All right. So let X equal pie sales. And we know our equation, 5% of $7,900, that's from the juice, plus 6% of our pie sales, X, came out to $650. All right, so let's see what he got from his juice. He's selling off that juice at 5%. $3.95. Maybe his pies are really salty, and that's why he has to get the juice sales, because people are like, oh, give me something to drink. He's like, I've got some juice for you. All right, we got to solve the equation. So we're going to minus 395. So he made $255 from the pies and commission. So if he is selling pies at a 6% commission rate, I'm going to go ahead and divide by 0.06. He sold $4,250 worth of pies. So Papa Smurf, my little hustler here. Papa Smurf. Sold $4,250 worth of pies. All right, next one. Number 11. Micah and her friend Anna want to give 20% of what they make at a craft fair to charity. If Micah makes $500 and they want to give a total of $150, how much will Anna have to make? Okay, I like to organize. You don't have to, but I like to. Micah isn't our problem. And Anna or Anna, who knows? She didn't tell me her name. And they're going to sell stuff. This is their sales. And they're going to give a percent. They're going to do a percent to donate. Okay. So this is our donation, or charity, I guess. Charity. Okay. And then we're going to have a total. And I reread. Mike and her friend want to give 20% of the money they make at the sales to charity. Okay, so down here, this is 20% of whatever they made. So 0.2 times whatever their sales were. If Micah makes $500 and they want to give a total of $150, that's going to equal $150. How much does Anna have to make? Okay. So I first think 20% of 500. So if she is doing 20% of 500, I'm moving the decimal over and multiplying by 2 to go 100. She came up with $100. That means that this little girl has to come up with $50 because they want to do 150. Well, I don't know what she sold. So I have to think 20% of what is 50. All right, so now I can go over and show my magic. Let X equal Anna sales. Okay, my equation, 20% of what Anna sells has to be equal to $50. So then I'm going to divide by 0.2 That is the same as 500 divided by 2. That is 250. So Miss Anna needs to sell $250 worth of stuff. What's she selling? Crafts. Crafts. Number 12. One more page to go. You can do it. You're hanging in there. You can always pause, get a snack, come back. If not live, you can take your time. A sales representative earns a salary of $1,314 per month, plus commission based on the total value of her sales. If she earns $1,484.40 for the month and her sales totaled $5,680, what is the rate of her commission? Okay, so I have to think about the organization here. She makes a base pay. She gets money for just showing up and not selling a thing, just being there. But then if she sells stuff, she gets a commission. And that will get me my total that she earnings. Okay, so that's kind of have to think about what I'm doing. And I don't know her rate of commission. So my X is going to be my rate of commission. So let X equal commission rate. So for me, this is going to be in decimal form. All right, so she makes her base pay. We have that as $1,314. Then she makes a commission rate, I don't know what it is, of her sales of $5,680. And that ended up with her earnings of $1,484.40. Okay, so I'm going to subtract 1,314 to figure out what is that she made in her commission. So some percent of her sales comes out to, let's see how much the total what she made in her commission. She made $170.40 in that commission. So then I'm going to divide by her sales. And I get X equals 0.03. She has a 3% commission rate. Her rate of commission is 3%. Number 13. A CD player that originally sold for $59.85 was discounted 15% in May. In June, the sale price was discounted 25%. What's the new price in June? All right, so we have original, May, June, and we are talking about the price. A CD that originally cost $59.85 was discounted 15%. Decrease. In June, the sale price was 25%. Decrease. Okay, so I have to think. If I am decreasing something by 15%, the percentage that I have left is 85%. So here, I have 85% of $59.85. If I'm decreasing something 25%, 25% off is 75% on. I have 75% of what I had before, and what I had before was this lovely expression here. And I'm trying to figure out what that is. Okay. So let X equal June's price. My equation, because I don't grade over there, I don't look at your organization. X is equal to 75% of 85% of $59.85. Okay. So I'm first going to go my 75% times my 85%. I'm really paying $63.75% of $59.85. So then I multiply times $59.85. And that will get us, we have to round a little bit because it's money, about $38.15. So in June, the DVD will cost $38.15. Now, some people go, well, why can't I just do a 40% decrease? Because you are not decreasing off the original price both times. Over here, this is a cheaper price. Remember, in May, if you were really to sit there and calculate it, in May, that new price is $50.87. It has some change on it that we don't want to delete because we'll lose it in the end. But over here, this is $50.87.25. Okay, 25% of that number is not 25% of that number. That's why you can't just add those two things. You actually have to sit there and do it twice. More commission, and it is our last problem. Let's do it like a rock star. An insurance salesman earned a commission of 3% on the first $5,000 of insurance that he sells each week, and 4% of the value that exceeds $5,000. 1 week, he earned a commission of $320. What was the total value of insurance that he sold during the week? Okay, he has like a tiered system, right? He gets a percentage of his first sales, and then it jumps up. So he has a tiered system. So here in tier 1, he's earning a certain amount. And then in tier 2, he has another amount, okay, to get to his total. And this is tier 1 commission, I guess. We can be a little bit more descriptive. I am not an English major. I don't like being descriptive, but I can be, because you have to be able to write. It's the most important thing. It's more important than math, actually. Okay, insurance salesman earned 3% of the first $5,000. Okay, so I'm going to assume that he sold $5,000. So here, 3% of $5,000 that he sells each week, and 4% of the value that exceeds $5,000. Well, I'm going to call the value that exceeds $5,000 my X. 4% X. 1 week, and he earned $320. What was the total value of insurance he sold during the week? Okay, so I have to be careful because I'm defining my variable not as a total. So let X equal sales after the 5,000. Just to make my equation cleaner. I can make it harder. I don't want to. All right, so here, from that first $5,000 that he's going to sell because he's a good little soldier, he's going to make $150. So $150. Then we get into the bonus tier where we're making a bigger percent, $320. I'm going to figure out how much he sold in that bonus tier. So subtract that 150. 4% of his sales equated to $170 of commission, which means he had to sell 4,250. But I have to be careful because mine is the sales after 5,000, and it said what was the total value. The total value, I had to take that 5,000 back. So my total, whoa, crazy line. My total was the first tier 5,000 plus my second tier of sales to get a total sales of $9,250. He sold. Whoa. He sold $9,250 worth of insurance. In a week. In the week. Okay. If you're electronic, hit save. You can go back. You can watch what you need to watch. Okay. Whatever you need to do. But for me, I am saying goodbye. Goodbye, all.